Hi there! Today we are going to be teaching you about transformational geometry by Raman and Anushka. Let's start with the basics. In transformational geometry we have reflections, rotations, and translations. But before that, let's talk about Cartesian planes. This is a Cartesian plane. There are 4 quadrants, 1 at the top right, 2 at the top left, 3 at the bottom left, and 4 at the bottom right. There are 2 axes, x and y. X is horizontal and y is vertical. In the x-axis, numbers to the right are positive and numbers to the left are negative. In the y-axis, numbers at the top are positive and numbers at the bottom are negative. The origin is where the 2 axes intersect. Cartesian planes are similar to grids, as you can see. When you are plotting a point on a Cartesian plane, you're given a set of coordinates, which is the x-coordinate followed by the y-coordinate. In this case, it's 4, 3. The origin's coordinates are 0, 0. Using Cartesian planes, we are able to rotate, reflect, and translate shapes. When we are rotating, reflecting, or translating a shape, the end result's points become known as prime. First, we will teach you about translations. Translations are essentially sliding the shape across this grid. In this case, we're moving it down. So we're moving it 1 space down, 2 spaces down, 3 spaces down, and now 4 spaces down. And this can also be done by moving the shape horizontally. Next, we will be teaching you about reflections. Reflections are basically mirror images which can be reflected through the y-axis or the x-axis. For example, if I were to reflect this image across the y-axis, it would look like this. This can also be done by counting the number of spaces from the mirror line to the shape on either side. Next, we will be talking about rotations. So simply put, rotations are basically just spins of any circular motion that are clockwise or counterclockwise. So, for example, this image is being rotated 90 degrees, and next 180 degrees, next 270 degrees, and finally a full 360 degrees. And this was just being rotated around the origin. You can also rotate shapes around a separate point rather than the origin. This is being rotated around 90 degrees about this point. So you can also combine transformations. This shape is first being rotated 90 degrees about point B, and then it's going to be translated down. And it's going to be 1, 2, 3 spaces, and after that it's going to be translated 2 spaces to the right. Now let's take a look at some real-life applications for all 3 transformations. So for reflections, in nature, a butterfly is a common example of a reflection because its wings are practically flipped, and it's a mirror image, meaning it's a reflection. Now let's talk about rotations. Rotations are commonly found in the wheels of cars and gears because it's basically any object that spins in a circular motion, which is a rotation. Lastly, let's talk about translations. Sewing machines commonly use translations because they have to sew vertically and horizontally, which is a translation. Wow, that sure was a lot of information, but we hope you learned a lot. Thanks for watching and have a nice day.
Created using Powtoon.